All right, sweet. All right. So yeah, welcome to my session for PostgreSQL. Um, so what is PostgreSQL anyway? Why is it so important, right? So PostgreSQL actually has some history on where a company, Ingress, was working on a project, and this guy here, let me see his name. His name was Stonebreaker. And basically he came back with a follow-up project, and it's the predecessor to Ingress, and it got its name Postgres. Now what's nice about Postgres is that it allows us to have persistence to data, which is very important. If you want to think about big teams, big projects, big companies, just a multiple like devs working on the same thing maybe, we are transferring data between each other. We might be working with that data and using files such as CSVs, maybe JSONs, whatnot, constantly trying to keep that data updated and between all the teams and constantly updated, constantly consistent is not really a thing, because you will have to constantly be uploading that new version, and people will have to be bringing it down and working on it. And I guess it's very similar to how GitHub version control works, where someone pushes an updated version and that pull request is accepted, that merge happens, right? And once that merge happens, whatever is local on your computer does not have those changes. So you need to go ahead and pull all those new changes. That's the only way. But thankfully, this guy came back and gave us a beautiful thing, PostgreSQL. And it allows us to have this persistence of data, which is very important, especially when you have scalable projects with huge companies, huge teams. And the other important thing is not only is it scalable like that, but it allows us to also build upon it. So it's an open source community and it's widely supported. There's a mirror version on GitHub, but you can't just do like a push to it or a pull request to it. You actually have to send a patch, and the patch they accept has a lot of requirements. So that's just some fun if you ever want to try to donate some code and try to do a patch for them. There are a lot of requirements, and you have to provide proof of test cases with your solution and a bunch of stuff. But it is an open source community, and it's has a huge tons of support. It being open source, that means it's free, right? So that's cost effective for any business, which is large scale. It makes it a viable option, makes it a great option. What's also nice about the PostgreSQL is it offers a wide range of features of working with XML, just all these different file types. It's very flexible. So different companies working with different files and different data, we can work with that in our database. And there's a database principle. It's called ACID. Let me scroll over here. So ACID is an acronym that represents a set of 4 key properties that are essential for ensuring the reliability and consistency of transactions in a database management system. So kind of like how you have the pillars of principle of OOP? The same kind of idea applies here with relational database systems. So you have atomicity, consistency, isolation, and durability. And Postgres adheres to that in the way it's built, the foundation of it. It also has security and authentication. So you have role-based access control. So in the company, they have a database system, and they're going to assign you a role, right? And they're going to assign all the employers a role, and this allows them so they can allow and disallow changes to certain data in their database. They don't have to worry about their data being manipulated by some random Joe, because now they get assigned different roles and have different access and privileges on editing or whatever you may do to that database. Today I want to go over some things that I think we maybe skimmed over or whatnot. And this would be the validators, the constraints, and the relationships and SQL schemas and building a schema and building your database. So our validators are rules or conditions applied to the data in a database to ensure that it meets specific criteria or follows certain rules before it is stored, right? So these examples could be checking that an email address follows a valid format. You can use regex to validate that, and then later on you will learn that other frameworks have models where you can use a validator model, such as an email field, and it will already have that ready format for you. And that's just another validator. So you make sure like the data you're taking in is the data you're expecting by the type that you're assigning or the restraints that you want. The other thing is verifying that date is within a certain range and ensuring that a numeric value is positive. These are validators that we can use to make sure our data is consistent when it comes in. Example of this is in this table of users where we do our check for our email. We can use check with a regex, and that makes sure like any email is not just coming in as any characters, any numbers. We're looking for a specific email format, and we can use regex for this. Now, regex is its own monster in itself. Even the most seasoned like devs will tell you like for a date format regex, they look it up. No one really memorizes that because it's really almost its own programming language because of how complex regex can actually get. And so let's go to constraints, right? So constraints are kind of like validators, but constraints are rules that are applied to the whole columns in a database table, and they define the limits or conditions that the data in a column must meet. So if we're making a users table, right, we would want a constraint on maybe not just the email, maybe we want a unique phone number. And this way we know when every time we have a user created in that table, we know each phone number is going to be unique and each email is going to be unique. We don't have duplicate data. That is one constraint we can apply to the whole column in that table. And we have some other primary or popular constraints. We have primary key, and this ensures each row in a table is uniquely identifiable. And we have a foreign key, which is where it has a referential integrity between related tables, and that gets into relationships, which we're going to cover right after constraints. And we also have not null. So you have not null to specify a field where you are saying that this is a required field of data that I'm expecting. So for like the username, maybe you make that not null. Everyone's going to have to make a username when they put in that data, or it like whatever data is coming in that's has to be filled out. That argument or parameter or field that needs to be filled out in that column because it's not going to accept any null. And these are and unique. I think I just covered that. Okay, I covered not null. So unique is very common, I feel like, and that's just what I said earlier, where you're looking for a specific unique entry of an email or phone number or whatever you may use it for. But these are very nice constraints, and it allows you to structure your data and have some persistence to what you're taking in. Using validators and constraints are very helpful because you're specifying what you're looking for and how you want it into your database. Next we have relationships, and this is probably one of the most important things about SQL. Not to get too romantic, but here's the juicy thing about relational database systems, right? We can create relations between data, between different tables. And some of the relationships we can create are one-to-one, one-to-many, and many-many. These relationships allow us to look at a table of data, right? And if there is a relationship between one of the data fields, between like one column between another column and another data, we can see both tables because of that relationship. We can see, okay, where user's ID is connected to another table, and we could join those tables and see both sides. But this allows us to connect those relationships and grab both information based on those relationships. And if we have that information, we can then further manipulate that in another function or whatever query you want to write. But relationships are very important to SQL because we are able to get this information and create our own joins of any of these relationships. And that could be a foreign key relationship, and any of these like one-to-many or many-many relationships. Now, when you're creating your schema for your database, for your relationships, you need to think about what kind of data relates to what, right? So if I have, let's say, if we go back to users, right? We have users, and then let's say this was users. We'll just use a movie store right now since we're coming up to that. But if we have users, maybe we want to make another table where it's videos, right? And the video is going to have a title, a rating, maybe a description. But a user could probably rent that out, right? Or maybe multiple users could rent that out. Maybe it doesn't have to be a one-to-one. Maybe it could be a many. And this allows you to create this relationship between tables, which is very nice. And you can see in Netflix how that would be very helpful. So a popular company that uses Postgres is Netflix. So something to think about is how would they be doing this? What does their like database, what might that look like, right? So let's think about what that might look like. I'll accept any answers if you guys can come up with tables or whatnot. We'll just make a few tables here. Okay, so does anyone think of like the first table?
Customers.
Was it
Users.
user? Okay, so yeah, we have users. Okay. What else do we have?
Movies.
Content.
We have movies. What was that other one?
I say content, but that's probably kind of encompassing.
Okay. Yeah, so we have movies. Maybe 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 a table for like watch history, and then I don't know, maybe
A list?
reviews.
Well, everyone has their own personal list. Like where you add your own movies that you want to watch later.
Yeah, so that could, yeah, so instead of reviews we could have like a personal, or we just have a watch list, right? So on Netflix is defining these tables within their platform or their program, and what they're doing is they're setting up these fields of these tables in their database of like, okay, users, what would that be? That would be like, so we probably have an ID, right? Which is most likely a, single primary key. And what that does is it's auto incrementing our ID. And this way, every user that is added to our database has a unique ID automatically. We don't have to add to it. When we insert data, we don't have to worry about it. SQL is doing that for us with that serial primary key serial constraint. So if we go to all right, ID, and then what we have like username, right? So like let's say username, and then username would probably be let's say a bar chart of 10 something. And then probably have like payment payment info.
Like
Which
subscription level.
I'm sorry.
Subscription level.
Yeah, subscription level. So maybe nerve so put that 50. I'm running out of the line here. That's okay. Sub level. I don't know the sub levels. I'm gonna assume that's also some sort of string that we're looking for. So maybe we have it like this, maybe they have a table like this. So let's build the movies one. What we got for maybe we got a title, right? That movies might have an idea, but let's say we have a title, and then we'll just say 255 because there's a lot of movies that I know that have long names. Then we'll probably have a rating, rating, and then what we can do is we can say like user ID or yeah, we're gonna say like user ID on the movies, and that's going to be an int that we're going to set, and we know that we're making this variable in our movies. This data in our movies, we're going to relate it to the serial. So think about it like this. And this is going to be okay. What were you saying, Shingen? I don't know. I saw his mic. So this is going to be our relationship here. Our user ID is going to relate to the serial primary key in our users table. And basically anytime we query for our user ID, we can join a table based on this relationship that connects users to movies. And that's kind of how I want to show relationships real quick without wasting too much time. Let's go back. Do I have any questions so far? No question?
Sorry.
Oh, you what? Sorry for what? Was it?
He said sorry. He unmuted himself.
Oh, okay. There's one thing I want to show you guys, which is very interesting. Let's see if I can just zoom out. Okay. So they actually have this interesting thing here where you all check out, put in chat. But it's a very funny manga PDF that teaches you about databases. I've not read it. I tried reading some of it, but it's very interesting and takes a funny approach to learning such a complex thing. So if you guys want to enjoy and sit back and read that, there's that. But yeah, let's get into practice in some of this because we're at the 20-minute mark and I'm worried how long this will take. So let's start here. So congratulations to CorpoPet Incorporated. You are a database dev for CorpoPet Company. Your project manager wants you to create a database which hold all your pet information, existing and new, and be able to request specific information back from the database. Yeah, so what would be the first thing we would do? I'll take anyone's answers. Feel free to speak up.
Would you go ahead and create a database in a terminal, or would you want to like shell out a like SQL file that has like your scripts for data fields?
Yeah, so there's two ways of doing that. So let me just change screens real quick. So if I stop sharing this screen and go to my Mac here, sharing this screen. All right, does everyone see?
I see a city.
Okay. So there's two ways we can create a database, right? We can go into our PSQL terminal here and we can say, create database and then whatever database you would want. So corpo pets store maybe, or center _ DB. Not caps though. Let's just not do caps. Corpo corpo pets center maybe DB. Okay, so we can create a database like that. Make sure you have a semicolon. And the other way to do it is to just do it outside PSQL. So if we just go ahead and drop this real quick. For pets, center, DB. If I spell that right, and semicolon. All right, cool. So let's hop out here. So we're in our normal terminal here. And I'm just gonna go to my desktop. So in our normal terminal, we can say we want to create a database outside PSQL. We can use these keywords, create DB, and it knows about it. It knows that when you type create DB, you want to create a database. And you can say create database, and then it's the same thing. You just enter the name of the database you want to call it. So what was it? It was like Corpo Pets Center DB. So boom, it created, and then now what you can do is you can say PSQL. Instead of trying to remember the name or anything, you're gonna hit tab, and it's gonna show you all your databases that you have. So we'll go to this one that we just made, and now we're connected. So currently we are in a empty database, right? What if we have data that is already from our store that exists? How would we, import that data to our database, right? So let's go over to a directory here I have, and we'll open it up. All right, so I have a directory here, and it just has this folder of data, and inside data we have these dogs, and we have these users. So let's go ahead. We have our database, right? And then normally at this point, you would probably start making diagrams of what you need. But we can just quickly think about what we would need for our database and create those tables just live real quick. So first we're going to need to create a SQL file, which will that's what we're going to use to load our tables in and essentially make those migrations, but I might be using the wrong term there. So we'll say corpo pets underscore schema SQL. So this is our SQL file, and what we want to do is we want to make these tables of our users and our dogs. A good thing is to just have them on the side here, maybe even split them. And then you can just have your data on the right. We'll also put the dogs over. Well, I'll try and put the dogs over here. There we go. All right, so now we have our dummy data for our store, right? So would anyone like to walk me through and creating our users table?
I can do it.
Yeah.
One moment. So I guess you would start with drop table if exist,
Okay.
right? I don't know if you necessarily need that, but I used it when I was messing with this.
Okay.
And then this is for users. Yeah, so users, and then create table users, open parentheses. And then we would then reference row 1 on the CSV here. So ID.
ID.
Yeah, ID, and that would probably be serial primary key.
Yeah, zero primary key. Now, you notice how IDs are already specified in the CSV file that we're going to load into our database later on, right? That will be worth note taking because this is a serial primary key, so it will give us issues, but I can show you how to walk around that.
Okay.
So we have name, right? Name's next. What's that?
So yeah, so name, and I'd probably do a varchar, and then I don't know, 30, 50, whatever. Yeah.
Yeah, that's okay. Name and email.
Yeah, email, varchar.
Varchar. 50,
Sure,
maybe I spelled it wrong.
And then phone num, I guess integer.
Um,
Or yeah, integer,
it could be either. We could
Oh.
just accept that as a string for right now
right? Okay. Cool.
because this isn't an integer we're doing any math with at all.
Okay.
So
Gotcha.
yeah, we can just leave that as a varchar.
Then we have dogs,
Then we have dogs.
which I would I guess I don't know exactly what that's referring to. Like the name of the dog or the quantity of dogs, but
So dogs is going be like our it's going to be our like maybe our list that the user has or something like that. Or it even could be a key to or like a relationship between the dog and the users. But yeah, we'll just have dogs.
okay.
And dogs, we'll set that as a varchar of 10 for now,
Mhm.
for time's sake. So in this users table, right, we have a phone number, an email, a name. So what are some like constraints that we want to think about with our users?
Well, if we want to make these required fields, would set them to not null.
Yeah. So what do you think not null? Maybe the email not null? You have to enter your email.
Yeah, I mean, I would say name, email, and phone number.
Okay. So now we're adding our constraints. right? Okay, so what if we have a user that signs up with an email, right? We have two people, same email. How do we stop that?
Oh, unique.
Okay. So maybe that's something we want unique.
Mm-hmm.
And we could apply that to phone number as well.
Yeah.
Okay. So we have our create table, our users here. We have an ID, which is going to be a serial, and this is going to auto increment. And we have the rest of our data here that we are using constraints, and we're saying that we need information for name, email, and phone number. Those fields need to be filled, otherwise won't be created. Okay, so let's create a table for dogs real quick. Why isn't it caption? There it goes. All right, dogs. So our dogs, we'll fly over here. Our dogs is going to be an ID. Same thing. We're gonna have our dogs maybe have primary keys. They're also gonna have names. So maybe we want to just copy paste this real quick. And then we'll have breed. And then breed is gonna be a bar chart. We'll have a 20. So with breed, if we use unique, right? That wouldn't work because you can have multiple dogs of the same breed. So if we had an extra dog here, a fourth dog named Jackson, and he was a German Shepherd, if we had unique there, it wouldn't accept that because now it's breaking that rule, that constraint that we set. So it's important to think about what data would be repeated, what data is not repeated, what data you want unique, and what data you definitely want not null, like you need to be accepted. So we have these two tables here. Did I missed age. Okay, let me do age, and we'll do aged. Age is just going to be a int. And then we can have like the owner, we're gonna have the owner ID as the int as well. So owner ID, and this is gonna be an int. And this is going to relate to our users table, the ID serial primary key here, the ID in our users. So after we define that we're going to have an owner ID, which is going to be an integer, we also need to say, hey, this is a foreign key, and it references this table and this data. All right, so we would say foreign key, foreign key, yeah, foreign key, and then we say owner ID, and then references user ID. Oh, users, sorry. Users ID. Okay. So now what this is saying, it's saying, hey, we have a foreign key. That foreign key is owner ID, which is an int, right? We're expecting an int. And that's going to reference this table users and specifically the ID. Okay. So if we have a dog here, and let's say we have Luna, right? And we give her the owner ID of 1. Okay. When we grab this information and take it into our database, it's going to set our owner ID for dogs to 1. and it knows that it's referencing the user's ID. Hold on, there's a question. Oh, I'm doing my math as well. So this is how you would set up a has a where each dog has an owner. Yeah, exactly. So, well, yeah, so if we put 1 for the owner ID, it's going to be a foreign key, right? That references our users table to that specific ID. So when we query for this data and we use the owner ID for the table of dogs, it knows to reference back to the user's table ID. And this is how we're building a relationship between the dogs and the users. And this is going to be a believe a one-to-one relationship. So now we have our tables created, right? We probably also want to drop the other table if we're going to do this multiple times. Otherwise, we're going to get the error that say, hey, this already exists, and we drop it. There we go. If exist dogs. All right, cool. So now we have our 2 tables. We're like, okay, boss man, I made the tables for a database. I made the database. I made the tables. I have the CSV data. Well, how's it look, right? So let's go into it. So we got PSQL, and we're going to use, I know I have 2 here, but let's just use the center one. So we're going to go into center, and we can use /d, and it's not going to find any relations. And that's because we didn't build it yet, and these are all of our databases. So if we use /d, it's just going to say nothing's in this database, nothing at all, because we haven't ran this. So we might want to just go ahead and run this real quick and make these tables. So we're going to use /i, and then we're just going to call the file really. Corpo. Oh, I have a. Oh, I wrote this wrong. Drop what? Drop table. I don't know if anyone else saw that, but there you go. That should be it. I think that's the correct syntax. Am I back in terminal? There we go. I'll try again. Nope. Okay.
You're missing semicolons at the end of your tables.
Oh yeah, I'm missing my semicolons. Thank you. So there you go. Definitely need those. All right. So we see this. We see the drop table and drop table. That's going to be from line 1 and 2. It's dropping those tables because they already existed, and then it's recreating those tables. And we can check if that worked by going in here and /d. So now, instead of no relations, we see all these relations that we have. We have the dogs, we have a sequence, which is the dog's ID sequence, and we have users as a table and users ID as the sequence. So if we were to say /d dogs, we can see that this is how our dogs found, I guess, lack for better words, foundation. That's how it's like laid out. This is how we're specifying the types. If it's nullable, and it's saying next val because it's generating the next ID, it's incrementing that. And it also shows you the foreign key restraints. But we can also check our users. And we can also see the dog's constraint, dog's owner, F key, the foreign key references the user's ID. and we can also see all these not nulls. And we also see that primary key and all these essentially validators, I guess you want to call it, of where we're only accepting the length of 50, length of 30, length of 10 for characters for those data fields. Right, so now we have now we have our database built and we're ready to put this data in. All right, so how would we put that data in? Does anyone know how we would take our CSV file and load that into our database? Not all at once.
So, you would do a I think it's a PSQL command in your terminal. So,
Okay, how would I write it in my schema? I want
Oh.
to say I want to do everything in my schema.
would it be just the same then? Would it just be like the database name? And then I don't know if it'd be the same or not.
The database name.
Like database name and then like the less than sign and then the corpo pets schema.sql. Would that push it into it?
No, I don't. I might be wrong. I don't think so. Just because that's not. That'd be you're writing terminal and you're not
Mhm.
writing SQL.
Okay.
Copy keyword with the or with the address or the path to the CSV file?
Was it?
Is it the copy keyword?
Yeah. So we want to use the word copy. And then we're copying what into what? We're copying data into dogs, right? So we want to specify dogs or users, however we want to do it. We'll do dogs first, that's fine. From where?
Talking from
This is where you put the absolute path to the data file you want.
Yeah, we can do that. So copy relative path. Or let me copy the full path. I don't know about that. Dogs, right? Dogs. We got dogs. Okay. So we want dogs and then make sure it's between single quotation marks. If you don't do single, it'll definitely give you another error. And then we're going to use our delimiter, which is just what's this separated by, and then it's a CSV file, which is comma separated values. And then we want CSV header, and that just takes the first line as the header. It knows about that. And I think this is it. This should load us our dogs. So, yeah, let's go ahead and run it. Into our SQL. Okay, what we got? Okay, copy dogs. We got dogs. Key owner not present in table users. Okay, so let's look at our users. Okay, so I think we might have to do users first because it depends on, we're having dependency issues. So let's go ahead and get our users in.
I don't know if it matters, Dakota, but in the CSV file for dummy dogs, only one entry actually has the owner ID for the foreign key thing.
Oh yeah, okay, I meant to leave that empty. Yeah, I'm not sure if that's the actual issue we're coming across right now.
I
And we
think
just
your
got-
issues, you're trying to drop the users first, but because the dogs table relies on it, it won't let you drop it because it has that foreign key in there.
Right. Okay. Let's just do this. Actually, I can just say dummy users. Dummy users. Okay. And it's really just the same thing. And yeah, depend on how it depends or how the dependencies are. Might have to switch it up here.
You never added users to copy either. I don't know if that matters or not. On line
I'm sorry?
21. On line 21, you never wrote users like to copy.
Oh, thank you. Yeah. Okay, cool. So user, we're gonna copy users, the table. Then we have our path from the dummy users, CSV. We're using delimiter of commas, and then our header is the CSV. Okay, and then it's probably gonna give us, oh no, okay. Says it drop the table, it create a table, copy three things, copy three things. We have three dogs and we have three users. Okay, so actually let's see what that looks like, right? So if we go here and we go, let's look at our dogs. So we're gonna select everything from dogs. All right, so we have all of our dogs here. And let's see what our users look like. And we have all of our users. So all right, so we know that now we're at the point where our database has our existing data. And we have built this database with validators and constraints of data that we're willing to accept. And we also built a relationship between the dogs with the owner ID that references our table users ID as the zero primary key here. And we could also say dogs, like dogs ID. And then we could do the same thing here, where instead of like int, it would be a foreign key that would relate back to here, but there's no need to really do that because we already had that relationship there. So there would be no reason why we would need to go back and forth, at least not for this exercise. All right, so now we know we have our database built. Let's look at, I'm gonna have to switch screens again. Back to our Excel. We have 10 minutes available. Okay, time flies fast. So let me switch back real quick. Okay. So we created our database. We went over the two ways. We created our schema and then we loaded our schema into our database, right? Well, now we have tickets. So this is where our queries come in hand. We have tickets that we have to fulfill, and there's information that we can retrieve and create, and now we can manipulate our data in our database. So just for starting, I guess, let's do ticket 2 real quick. We're gonna knock out ticket 2 in like 2 minutes, 1 minute. All right, so I didn't realize how much I would have to switch back and forth in retrospect. I should probably just stick to one computer, but yeah, let's do ticket 2, and I can read the other tickets, and that's fine. So on ticket 2, we'll go back to our code here. Okay, So ticket 2 is saying we have a customer that wants all the dogs in our inventory. How would we do that?
Select asterisk from dogs.
Select star from dogs.
Yeah.
Okay. And then see, there you go. All right, so we got all of our information here with our dogs. Okay. We have another ticket here. Let me look on our ticket board. Sorry, this is the fun thing I try to do. We have a new user that wants to register with our pet center. I have information. His information is Jack Rhodes. This is his phone number, 9867 7823 123 123 too many. Okay. And then his email is road on the road at Gmail. Okay. Yeah, so we have this customer. So how would we get this customer in our database?
Insert into users.
Okay, so insert into the users.
And then the things we want to add would just go in parentheses.
Okay.
Each thing, right?
Yep. So let's look at our users, or we can even probably scroll up here. I'll look at. I'll just look at the CSV, right? So we know ID. We're not going to enter ID. That's auto for us. We're going to need a name. We're going to need an email, a phone number, and dogs he has, right? So these are the fields, and then this is the values we're taking in. So his name is Jack Rhodes. His phone number, I believe we made it a varchar of 30. So you gotta have three phone numbers in here. So that's another thing. It's like, what's another thing to think about? Well, phone numbers are usually just 10 numbers or 11 number if you add that very beginning. I forget what that's called, but you know I'm talking about, the 1, then your area code number. So maybe I should have made varchar 12 or 11 in hindsight, but these are just things to think about when you're creating your data. So Jack Rhodes, it's a string of whatnot. We actually have his number right here, so let's just put that in. Right, and then we have, oh, I forgot his email. So let's do his email. So his email is going to be road on the road. Okay. And then dogs, which we can just null. We can just say null. And then semicolon. That should be everything we need. And when we load this, he should be added to our database, right? But think about the primary keys. We might run into an issue with that, right? So let's see.
Is your screen like paused or frozen? Because I don't see anything.
Is everyone seeing my screen correctly?
Yeah, I can see it.
I'm seeing it.
Yep, I can see it.
All good.
Okay. I'm not sure why you're not able to see my screen live. But if we run this, we're gonna get this
Those quotes be single quote.
error. I'm sorry?
The quotation marks, they should be single quotes, right?
Yeah, they should be. Yeah, let's do that. Let's fix that. Okay. Saying Jack Rhodes, over the mail. Okay. Okay, so now we're getting that error I was talking about. So it's saying that when we put Jack Rhodes in, it's trying to give him a primary key of 1. But we already have primary key of 1. But the primary key, I guess, aggregator you can think about doesn't know that what our max is, well, what our like current ID is. And in this, it's 3, right? If it knew about being 3, it would try to set Jack Rhodes to 4. And this is where we need a special command to set the value of the primary key to our highest. And this could just be written real quick, like this before our time is up. But we're just gonna set the value. This is where our sequence comes in. So if you guys remember when I was doing the slash undercase D, we were able to see our tables and our sequences. So we're grabbing the sequence, and then we're saying select the max ID lowercase, the ID lowercase from I don't know what's not. There you go. From. And from should be this one's from dog. So it should probably be from users, and we can just change this to users. Okay. And then we need our semicolon. All right. So this is, let me comment this out. It's just setting our new val, or attempting to. Hopefully it just runs through. But basically, if you already have existing data and you're setting primary keys, it won't know about that. So you have to reset the value. And that's what we're doing with this. And it sets the value to 3. So it knows about 3. So now when we insert this new data, it knows about 3. It's going to set Jack Rhodes' primary key to 4. And then it says insert 0, 1. I accidentally ran this line again, but it says 3. You can see here, set val 3, and then insert 0, 1, so we can actually see that working. And if we call users, not like that, we select users. Oh, I forgot, select from users. And now we see Jack Rhodes with the ID of 4. There's other tickets, but we don't have time. I tried to make it somewhat fun. Unfortunately, I ran into some errors there, but thank you for the help. I do appreciate the small help. And yeah, I hope people or everyone that was in here watching learned something a little bit about some SQL and why it's so important and why we have these relational database systems.